A light rain is just past, and the sun steps out from behind a soft sheet of clouds. Air smells clean. The world looks washed and quiet. Far ahead, a gentle arc begins to glow, almost as if the sky has painted itself with a soft brush. Welcome to a slow, relaxing walk through the science of rainbows. Settle in, let your breath follow a calm, even rhythm, and allow this simple scene to open like a bedtime story. What city/country are you watching from right now? Sunlight may look plain and white, but inside it hides a blend of many colors. You see this sometimes in a thin film on a puddle, or in the shimmer on a soap bubble, or through a crystal held near a window. The colors are always there, resting together in the light. Rain and sun help those hidden colors step apart in a gentle, orderly way. The sky becomes a quiet stage. Each raindrop is a tiny performer. The sun is the steady lamp that lights them all. Picture a single raindrop near you, not the shape of a cartoon tear, but closer to a small, rounded bead. As it falls, moving through the air, it can flatten a little at the bottom, like a very small hamburger bun. But to a first glance, it is close to a sphere. A ray of sunlight reaches it. The light does not simply bounce off. Some of it goes in. At the surface, the light slows down and bends a little, the way a runner slows when stepping from dry ground into shallow water. That gentle bend is called refraction. It happens because light moves at different speeds in different materials. Air is one kind of material. Water is another. This change of speed and the gentle bend at the boundary make the path of light curve inside the drop. Now, white light is a blend. The bend is not the same for every color. Red bends a bit less. Violet bends a bit more. Blues and greens and yellows sit between. Inside the raindrop, that one sunbeam spreads into a small fan, with each color following its own quiet path. The beam reaches the back of the drop, and there, a part of it reflects, like a mirror that is not quite perfect, but still bright. That reflected fan turns back toward the front of the drop. It meets the surface again and steps out into the air, bending one last time. Those two gentle bends and that one reflection are enough to separate the colors cleanly. It is a simple path, but it is also very precise. From one drop, this looks like a small glimmer. From many drops, spread through the sky, it becomes a smooth arc. This is because you do not see just any light that leaves the drop. You see the light that leaves at just the right angle for your eyes and your place on the ground. The angle for the strongest red light, after that inside reflection, sits around 42 degrees away from the direction opposite the sun. The strongest violet sits closer to 40. Each color has its own favorite angle. That graceful ordering is what lies behind the shape we call a rainbow. Stand with the sun behind you. If the rain is ahead, each drop sends its colors in many directions, but only those sending red light to you at about 42 degrees will make the outer red edge of your bow. Those sending violet to you at about 40 degrees will make the inner edge. Green and yellow and orange fill the space between. To your left, other drops at those exact angles send you the same arrangement. To your right, the same again. All of these points all those perfect angles, form a circle centered on the point directly opposite the sun. A point in the sky that hides behind your head and your shadow. The ground cuts that circle, so from where you stand, you see an arc. From a plain, or from a high mountain with mist below, sometimes the full circle appears, and it feels like looking into a softly glowing wheel of color that moves with you as you move. Each person sees their own rainbow. This is not a metaphor. It is a practical truth about light and geometry. If you step forward 5 paces, the set of drops that send you that perfect 42-degree red is now a different set. The bow looks like it has moved, because it has. Your bow is always anchored to the line from the sun, through your eyes, to the rain. A friend standing 10 steps away is seeing a bow similar to yours, but not the same set of drops. This is why you can never walk to the end of a rainbow. There is no single place where it touches the ground. It is a direction, not a location. It is a pattern in the light as you stand in one spot and look outward. When the sun is low, near sunrise or sunset, the 42-degree cone of red reaches high into the sky, so the rainbow arcs tall above the horizon. As the sun rises, the cone tilts downward. Near midday, the arc shrinks, coming closer to the horizon, and sometimes it hides altogether because the rain ahead sits too low in the sky to intersect those special angles. This is why late afternoon showers often produce generous bows, while sharp summer rain at noon does not. The angle is constant, but the shape you see depends on the sun's height and on whether there are enough drops positioned to meet that angle. Sometimes, a second arc appears above the first. It is usually fainter and wider. Its colors are reversed, with red on the inner edge and violet on the outer edge. This happens because inside some drops, the light reflects twice before leaving. That extra reflection sends the strongest light out at a bigger angle, near 51 degrees for red. The extra bounce also spreads the colors a bit more and loses a little brightness along the way. Between the primary and the secondary arcs, there is often a darker band. The drops send less light into this zone because most of the rays either come out at the primary angles below or the secondary angles above. This dim area has a historical name, but you do not need to remember it to enjoy how the contrast makes the two bows look clearer. The sky itself seems to shade in the gap, like a careful artist working with light. If the drops are very small, as in a fine mist near a waterfall, or a lawn sprinkler on a gentle day, you might notice extra pale bands tucked just inside the violet edge of the main bow. They look like faint pastel echoes, very close together. These are called supernumerary bows. They arise because light behaves like a wave as well as like particles, and waves can add together or cancel out depending on how their crests and troughs line up. Inside the drops, the wavy nature of light makes certain paths brighter and others dimmer, especially when the drop size is uniform and small. The result is a delicate set of fringes. You do not need to solve any equations. You can just let your eyes rest on the idea that rainbows also carry tiny, invisible ripples of light that create gentle decorations along the edges. Drop size matters in other ways. Large, fresh raindrops tend to make brighter, more vivid bows with clear color bands. Fine mist can spread the colors so that the bow looks softer and paler, sometimes almost white. The exact shape of the drop plays a role too. Falling drops flatten slightly, and this shape can tilt the brightness, making the top of the bow look a bit more intense than the sides in some conditions. Hazy air and sun glare can dull the scene, while a dark background of retreating rain clouds boosts the contrast and makes the colors sing more clearly, even though the whole display is still gentle and quiet. You can make your own simple rainbow with a garden hose on a sunny day. Stand with the sun behind you. Let the water spray into a fine mist and slowly rotate the spray in front of you. Somewhere the colors will appear, and you can move the hose to paint your own arc into the air. The bow will follow the same rules as the one in the sky. Red forms on the outside, violet on the inside, and the arc sits at the familiar angles. If you walk forward or backward, the colors shift with you. This is the same dance of angles and drops, only closer and smaller. It is safe, soothing, and surprisingly beautiful. There is also a quieter sibling of the rainbow. When the moon is bright and the night is humid or misty, a moonbow can form opposite the moon. The light is weaker, so your eyes, which rely more on light-sensitive cells at night, see little color. The arc looks pale or even white. A long camera exposure can uncover the colors that your eyes miss. A moonbow is the same physics, the same geometry, and yet it feels different because the world is quiet, the air cool, and the sky dark. It is a soft surprise that shows how the rules of light do not rest when the sun goes down. In deserts, in coastal spray, along the path of a waterfall, rainbows often appear even without a storm. The fine droplets in the mist provide the medium. Sunlight does the rest. If a lake or sea reflects the sun, you might see a reflection rainbow, a second arc that seems to hover lower, born from sunlight bouncing off the water before it reaches the drops. Sometimes, when the rain contains two distinct sizes of drops, a twinned rainbow can appear. It looks like the main bow splits into two side-by-side arcs of similar width, rather than the wider reversed secondary. This is a rarer sight, and it reminds you gently that the shape and structure of tiny droplets can change the pattern that meets your eye. If you wear polarized sunglasses and tilt your head, you might notice the brightness of the bow change a little. The light from a rainbow is partially polarized because of the way it reflects inside the drop. Polarization means the waves of light tend to swing more in some directions than others. Sunglasses that favor one direction of swing can pass more of the bow's light or less, depending on how you tilt them. This is a small detail, but it shows that the rainbow is not just about color. It is also about the deeper habits of light, the quiet ways it moves and interacts. The story of how we came to understand rainbows is itself a calm stroll through observation. Many people looked and wondered across centuries. A range of ideas appeared. One key step was to think about how light bends when it passes from air into water. A simple rule can relate the angle before and the angle after, depending on how much slower light moves in water than in air. Water slows it by a fixed amount, though that amount depends slightly on the color. That slight dependence is called dispersion. It is the reason a prism spreads white light into a spectrum. A raindrop is like a tiny, somewhat rounded prism that the light passes through and reflects within. Later, another crucial step came when someone used a prism to split sunlight and then used a second prism to recombine it, showing that white light is not pure on its own. it is a blend. These steps connect the quiet physics of a single droplet to the wide arc in the sky. The order of colors in the main bow is consistent. Red sits outside, then orange, yellow, green, blue, and violet closer to the inside. You may have learned a list of names to remember this, but it is good to know that the spectrum is continuous. There are more shades than any list of names can hold. Also, violet and purple are not the same. Violet is part of the spectrum, with a shorter wavelength than blue. Purple is a blend in our perception, made by combining red and blue light. You will not find purple in the rainbow spectrum. The rainbow carries only the colors that arise from single wavelengths of light. Our eyes, with their 3 types of color-sensitive cells, take that continuous flow and turn it into the colors we feel and name. Under bright light, the cells for color work well. In dim light, the cells that measure brightness take over and colors fade. This is why moonbows look pale. A rainbow's position is centered on a point directly opposite the sun, the anti-solar point. If the sun is behind you and low, your shadow stretches long, and the head of that shadow points toward the center of the circle. In a plane, you might see a circle instead of an arc, with your plane's shadow sitting at the center if conditions are right. Around that shadow, you may notice a different phenomenon, a small, bright set of colored rings called a glory, caused by a different kind of scattering on tiny droplets, with light bending and circling the drops in complex ways. Glories are not the same as rainbows, but they share the stage and add to the quiet beauty of looking into mist from above. Inside a drop, the primary rainbow path involves 1 reflection. The secondary involves 2. In principle, the light can reflect 3 or 4 times and still leave the drop. Such paths exist. The angles for these higher-order bows sit on the same side of the sky as the sun. They are much fainter, and the bright glare near the sun hides them. With careful photography, stacking images and shielding the lens, people have recorded tertiary and quaternary rainbows. You do not need to see them to feel a sense of completeness. It is enough to know that the raindrop is a patient laboratory, with many paths possible for a single beam, each path whispering a different angle and color. The brightness of the primary bow is not even. The top often looks stronger than the sides. This can be because of drop shape, because of the angle of view, or because of contrast with clouds behind. After a summer storm, when dark clouds still hover ahead and the sun peeks out from behind you, the scene sets itself perfectly. The dark background makes the colors clear. The air has been washed of dust, so the light scatters less, and the bow sharpens. It is as if the sky itself is helping you see the geometry that was always there, waiting for the right conditions. Imagine standing near a waterfall. The sound is soft and steady. You move a bit so the sun sits behind your shoulder. A halo of color floats in the mist. You step to the side and the halo follows, anchored to your eyes and the sun. This personal quality is part of the charm. The rainbow is both a fact of physics and a private sight. Each angle from each drop is honest and strict. And yet the whole display feels like a gift meant for the one who happens to be standing there, at that time, in that light. On the surface of a calm lake, the sun's light can reflect upward into the rain, and a reflection bow appears. It sits below the main bow. The geometry is similar, But now the path includes a bounce from the water. The reflection of the sky changes the center of this bow, stretching it in a way that makes the shape look flatter. It is a gentle twist on the theme. In the right spot, you might catch the main bow and its reflection friend together, like two soft parentheses holding a sliver of bright sky. There is also a ring of story and symbol around rainbows. Many cultures share tales of bridges, promises, or treasures. These stories are warm and human. They map feelings onto a shape made by light. It is fine to carry both kinds of knowing at once. The quiet comfort of a myth can sit beside the quiet clarity of an angle and a droplet. In your mind, both can calm and soothe. Both can help you linger in the moment when rain and sun coexist. The blue of the sky plays a role in how colors appear. The air itself scatters shorter wavelengths more than longer ones, which is why the daytime sky looks blue and why sunsets lean toward red. This scattering also affects how vivid a rainbow looks. If the sun sits behind a thin veil of cloud and the sky is milky, the bow may look faded. If the air is very clean after a storm, the colors can glow in a way that feels rich, yet still polite. The bow is never harsh. It does not flash. It simply hangs, slowly changing as the sun moves and the rain drifts. Our sense of distance and scale can be a little slippery with rainbows. The arc looks like it sits out in the rain ahead, and yet, if you drive toward it, it keeps its shape and distance. There is no single place in space where the bow exists as a thing. It is a map drawn by the directions of light that reach your eyes. The outer red comes from drops higher up than the inner violet. The whole band is a cone of light that intersects your view. This little piece of geometry is a soft mental exercise. It shows how a stable, beautiful scene is built not from a solid object, but from countless tiny events that add together into something grand. As a drop falls, the path inside it can vary slightly. Some rays reflect and leave with a range of exit angles near the best one. This gives the bow a gentle width, not a razor-thin line. Red is not a single line, but a soft band. The same goes for each color. The overlap between these bands is one reason green, which sits between bright yellow and blue, sometimes looks narrower or less intense. Your eyes also have different sensitivities to different colors. That is okay. The bow does not mind how you see it. It offers what it can, and your eyes take what they will. A prism shows a spectrum on a wall, but a prism is a single solid object. A rainbow is different. It is the collected work of millions of tiny droplets, each doing the same simple thing. Consider how gentle and patient that is. Each drop is small, nearly weightless to your hand. Each one bends light in the same way. Together they build a clean curved band that you can see from far away. This is one of the quietly satisfying parts of physics. Many small, simple pieces can create a large, elegant pattern. If you ever see a rainbow with unusually intense purple at the inner edge, you might be seeing a contribution from overlapping violet and blue that your eye blends with the red from the other side of the spectrum reflected from other drops. The eye is an active partner in this dance. It has its own habits, its own gentle biases, and the brain interprets what the eye sends. When you are tired or when light is dim, your perception shifts. The bow may look different at different times of day, even if the physics is the same. because your own system for seeing changes its balance. When sunlight passes through the atmosphere at a low angle, it travels through more air. More air means more scattering. The red part of the spectrum is scattered less and travels more easily, so near sunset, the sun takes on a warm color. If a rainbow appears in that time, the red and orange bands can look wider and more dominant, while the blue and violet bands may look a bit subdued. This is not the raindrop changing its mind. It is the sunlight changing its mix because of the long path through the air. In the soft warmth of evening, this adds to the feeling of calm and rest. In some places, mountain valleys make rainbows more common. Moist air rises in the afternoon, clouds build, rain falls. And then, as the sun lowers, the first breaks in the clouds appear in the west. With the sun behind you and rain ahead, the recipe is perfect. If you live in a place like this, you may see bows often. If you live in a dry place, they may be rare. But a fountain, a sprinkler, or nearby waterfall can bring the phenomenon to you in small scale. It is nice to know that a simple garden hose can bring a soft arc to life on a quiet weekend afternoon. Cameras capture rainbows differently than eyes. A camera sensor may saturate certain colors, or a lens may produce flares or rain spots. Polarizing filters can change the look of the bow, sometimes deepening the colors in the bow, while also darkening the sky. Long exposures at night can reveal moonbow colors that your eyes gloss over. Neither way of seeing is better or worse. They are different ways to explore the same steady geometry. Think for a moment about the exact path inside a drop. Light meets the surface. It splits because part reflects and part refracts. The refracted part bends in, spreads by color, touches the back, reflects, and heads back out. The angle at which most of the light emerges for each color is not random. It nudges toward a specific direction due to how the drop's curvature and the light's bending interact. This creates a region of concentrated brightness, a caustic, that your eye traces as the bright arc. The word caustic may sound sharp, but here it simply means a place where many paths focus together and make a bright edge. The bow's edge is such a place, a line of enhanced light set by geometry. Artists sometimes paint rainbows with a solid band of 7 named colors. The real sky will show you blends that are smoother. Between blue and green, there are many sea shades. Between orange and red, there are many warm tones. You can let your eyes wander across the band and notice how the shift is gradual. The mind lacks boundaries, but the light offers a continuum. That softness suits the goal of sleep. It is easy to rest while watching a gradient. From a plane flying above light rain, the full circle of the rainbow can look like a hoop floating in space. Sometimes, as the plane moves, the circle seems to stretch or wobble. It is still the same cone of angles. Now you are high enough that the ground no longer cuts the circle, and enough mist lies below to complete the ring. Around the plane's shadow, if the droplets are small enough, you might see the glory, a tight set of colored rings with red on the outside and blue toward the inside. The glory arises from surface waves of light circling the droplets and reuniting behind them. It is another quiet reminder that light is both wave and particle, and that small spheres in the air can do elegant things with it. Sometimes, Thin clouds in front of the sun produce halos and arcs that are not rainbows. Those are caused by ice crystals high in the atmosphere, and the geometry involves hexagonal prisms instead of round drops. They have their own calm beauty. The rainbow remains the domain of liquid water droplets. When both appear at once, the sky becomes a gentle geometry lesson written in light, with circles and arcs and bright spots to trace with your gaze. Out beyond Earth, other worlds offer their own versions. In a methane-rich atmosphere, if sunlight meets methane rain or mist, the dispersion differs, so the angle for the bow changes. Saturn's moon, Titan, for example, has thick haze and methane rain in some seasons. Models suggest that a rainbow there would be centered on the anti-solar point, just like ours, but with a different spread of colors and angles. The thought is calming. The same simple rules extend quietly into the wider solar system, changing little details according to the local materials. There is a sense of unity in that, a sense that light follows its path with grace, no matter where it travels. The feeling you get when a rainbow appears can be a blend of gratitude and calm. The storm has passed or is moving away. The air feels fresh. The sun warms your shoulders. The bow tells you that the sun, the air, and the water are in a temporary balance that lets the colors show. You may take a slow breath and let your eyes rest on the arc for a long minute. This is the kind of science that sits quietly in the background of your day, asking for nothing, simply present and soothing. Now let us stroll a little deeper into the numbers, but gently and without weight. Water has an index of refraction that is a little higher than air. That index depends on color. Because of this, red light, with a longer wavelength, bends a bit less than blue light, with a shorter wavelength. Inside the drop, the angle of incidence and the curvature work together to make a spread. For primary colors, the steepest gradient of brightness concentrates near 42 degrees for red. This is why red is on the outside. Blue and violet, bending more, come out at slightly smaller angles, sitting inside. The secondary path, with two reflections, shifts those angles outward and flips the color order. The darkness between the bows arises because those paths do not spill much light into the region. Think of it like a crowd moving down two separate ramps, leaving a quiet space between. If you look closely at a vivid bow, you may notice that the band of green sometimes feels narrower than red or blue. This is partly because the human eye is less sensitive to pure spectral green, and partly because the distribution of light within the bow places a little less emphasis there. The overlaps between bands blur the edges. The result is lovely and varied. You can let this detail pass or linger on it as you like. Either way, the bow stays calm. There is also a small effect called chromatic aberration that lenses have, where different colors focus slightly differently. Your eye is a lens. This can soften some colors. If you shift your focus, you may bring a different part of the band into sharpness. This is a private little skill you can try gently while looking at a safe bow. It is a way to interact with the scene without changing it. Just a tiny change in focus and the colors change their crispness. Sometimes snow flurries followed by sun can produce tiny rainbow-like effects in the air if the flakes melt into droplets as they fall, or if the snow turns to drizzle. If you see colors in ice crystals, that is a different family of arcs, often at 22 degrees around the sun, caused by hexagonal ice prisms. Both are friends to the lover of sky optics. Both can fill your day with quiet interest, free of any rush. A rainbow can also appear in the spray from the ocean when waves crash and fling droplets into the air. If you stand on a pier with the sun behind you, you may see a short, glittering bow in front of the spray. It rises and falls with the wind. The colors shimmer. It is the same physics, only in a lively, flickering form. You can let the motion lull you, like watching a fire or listening to soft rain on leaves. Sometimes after a storm, you may see a double rainbow whose primary bow has a bright, almost glowing red. This can happen when the sun is very low and the path through the air filters out much of the blue light. The red that remains stands out. The landscape under the bow can look unusually vivid because the sky is darkened by rain and the sun behind you shines like a spotlight. Photographers call this sweet light. You can simply stand in it and feel the day letting go. You can also notice how the space inside the primary bow often looks a little brighter than the space outside. This is not your imagination. The bow sends some extra light into the region inside, while outside it sends less. The secondary bow sends some extra light outside its arc, which can change how the outside region looks when both bows are present. These are small differences, but they add to the sense that the bow is a real pattern in the light, not a trick. If you find yourself daydreaming about the math inside a drop, keep it friendly. Imagine tracing a path with a finger on a curved glass bead. In at one point, across, bounce, and out again. The angle you start with matters. Most angles do not produce much outgoing light. Only those near a special entrance angle make the strong exit near 42 degrees. This is why the bow is bright along its edge and fades inside. The exiting rays crowd together there. The drop acts like a gentle funnel that sends many paths toward the same direction. That crowding is what your eye catches as the arc. When the sun is very low, the rainbow can seem to touch the ground far ahead, where rain still falls. You might see it over a field, a road, or buildings. The contact point is not fixed. As you move, it moves. Drivers sometimes notice the bow keeping pace with the car, hovering over the same patch of road in the distance. This is a good reminder that the bow is relational. It lives in the connection between your eyes, the sun's position, and the rain. Change any one of those, and the scene changes. If you want to see a rainbow, you can make the conditions friendlier. Watch the weather. After a passing shower, as the sun peeks out from the western sky in the late afternoon, look east. If you see a curtain of rain and the sky is dark behind it, your chances are good. Even if the bow does not appear, the act of looking slows you down. You notice cloud textures, shifting light, and the smell of wet earth. That alone is a comfort. Even on dry days, you can meet the spectrum in a home experiment. Hold a clear glass of water on a sunny windowsill. Place a white card or sheet of paper in the path of the refracted light. Tilt the glass gently. A small rainbow of light will fall onto the paper. It is a miniature version of the prism trick. The water acts as a lens and a weak prism, bending the light by color. Move slowly and notice how the band broadens and narrows. All of this can be done safely and quietly at a table with a cup of tea nearby, which is a nice combination. Let us return to the sky. The secondary bow, with reversed colors, sits about 10 degrees away from the primary. It is usually dim. Sometimes it looks almost the same brightness as the primary, if the drops are plentiful and large, and the sun bright. Between them, the dark band stands out. This is one of the places in nature where you can see a stark contrast drawn by nothing more than the path of light. It can feel like a visual sigh, like a breath held between two phrases of a song. When you stand under a sky with a wide, clear bow, you stand inside a cone of angles centered on the line from the sun through you. If a cloud moves across and breaks the rain, parts of the arc vanish while others remain. This is not because the bow is broken. It is because the drops that were sending you the right light in one area have drifted away, while others remain in different places. As the rain shifts, so does the pattern of drops that meet your angles. The arc blinks like a lazy eye, and then opens again. Some people notice a faint, straight beam or a brighter region below the primary bow near the horizon. Reflections of light in the wet ground, or multiple scattering in heavy rain, can create small enhancements or variations. The human eye is good at finding patterns. It is also good at ignoring small ones when the whole picture is strong. Both traits serve you well when looking at rainbows. If you want to see, you can see a great deal. If you want to relax, you can let those details blend into a single smooth impression of color and curve. In art and design, rainbows often symbolize inclusion and unity. In science, the same words apply. The bow includes all single wavelength colors. It unifies the behavior of light across countless drops. It links a storm and sunshine. It sits at the meeting of air and water. It is peaceful even when it is bright. If you bring that feeling into your evening, it can help the mind let go. There is a small effect called deviation that measures how much a ray's direction is changed after passing through the drop and reflecting inside. For the primary bow, this deviation has a minimum value at a certain entry angle. Rays near that minimum deviate by almost the same amount, so they leave the drop in nearly the same direction. That crowding of directions is the reason the bow has a bright edge. For the secondary bow, a similar minimum appears at a larger deviation, which corresponds to the larger angle from the anti-solar line. This language can sound technical, but the main idea is simple. The drop prefers to send light out at certain directions, and those directions trace a circle in the sky. You might wonder what sets the exact number 42 degrees for the red edge. It comes from the index of water for red light and the geometry of a sphere. If you changed the liquid, the angle would shift. For glass, a similar effect has different angles. For a denser liquid, the bending is stronger, and the bow would sit at a different size. This is one reason the thought of a methane rainbow on another world is so pleasing. The same structure appears, but with a gentle, alien tweak. The air around you is full of tiny particles. Dust, pollen, and small droplets scatter sunlight. If the air is hazy, the background can glow a little, reducing contrast. If the air is clear after rain has washed it, the background darkens under the clouds, and the bow stands out. You can feel this in your body as a sense that the world has been cleaned. Colors in the leaves, the road, and the buildings sharpen. The arc adds to that feeling, like a last ribbon on a pretty package. Human eyes vary. Some people see more shades. Some are more sensitive to blues. Some have mild color vision differences. Each person's rainbow is literally not the same as their neighbor's, even beyond the geometric fact that they see different sets of drops. This private quality is part of what makes a rainbow a good partner for sleep. It lets you have an experience that is both shared and personal at once. On a day when sun and rain alternate, you may see a bow, then sun, then another bow later. If the drops in the second shower are different in size, the colors can look different. This is a reminder that nature is full of small variations. The rules are stable, but the inputs change. You can embrace that flexibility as a calming thought. The world is reliable, but never mechanical. It is alive with detail. You can take a slow breath now and return to the first image. The light rain, the sun coming back, the start of an arc, the feeling in your chest when you notice it, the way you want to share it with someone or simply stand alone and soak it in. That feeling is part of the science too, because curiosity stands beside the urge to relax. Both bring you here. Both keep you gently awake or let you drift off as you prefer. On the other side of the physics sits the idea of white light. Many daily lights are not purely white. A candle, an incandescent bulb, a warm LED, a cool fluorescent lamp, each has its own spectrum. Under those lights, colors in a room look different. The sun is a broad, near-white source at midday and warmer at dawn and dusk. The rainbow shows you the sun's mix directly. It is a natural spectrum spread across the sky. You are watching the daylight unfold, not from a lab instrument, but from a raindrop. It is as close to a direct conversation with sunlight as you can have without touching the sun. If you stand very close to a spray, the arc can look like a complete circle around your shadow if the mist surrounds you. The center sits at your shadow's head. It follows you as you move. Because the drops are near, you can see the structure vividly. Supernumerary fringes show up easily here. This is a safe and gentle way to gaze at fine rainbow details. You can let the spray cool your face and listen to the hum of water while you explore. You may have heard people speak of 7 colors in a rainbow. The number is a choice, not a rule. Some cultures pick fewer or more. The spectrum does not divide itself into strict boxes. The choice of 7 has a historical story behind it, connected to ideas of harmony and music scales. It is a nice story. The sky is happy to offer any number you like. You can count 5. You can count 9. Both are fine. The light itself does not mind. Rainbows also show up as small, patient teachers in classrooms. A glass prism, a water-filled flask, a compact disc with tracks that act like tiny mirrors. All can split the light. These are practical demonstrations of the same gentle principle. Light carries many colors. When those colors are guided by a surface or a medium in a careful way, they step apart and you can see them. This can be a restful thought before sleep. Even in a busy day, the parts of the world you do not notice are waiting, ready to reveal themselves when the angle is right. If you slowly rotate a clear crystal in sunlight, you may see tiny rainbows paint the walls. This is a cousin to the sky's bow. It comes from refraction and reflection in the crystal. The colors are small, but they carry the same quiet delight. In the evening, the low sun can turn these room rainbows into long bands that move like whispering scarves across your ceiling. You do not need to chase them. Let them drift. Another small kind of sky bow is the fog bow. In very fine fog, the droplets are so small that the colors blur together, and instead of a rainbow,
you may see a broad, pale arc almost white. This is related to the supernumerary phenomenon. The wave nature of light spreads the colors when the droplets are tiny and uniform. A fog bow looks like a quiet ghost of a rainbow. It is a gentle sight on a cool morning, especially on a trail or over a field before the sun warms the air.
Sailors sometimes see fog bows and rainbows at sea. The open horizon and uniform conditions make them easy to spot. The arc can span the whole distance from one side of the world to the other in a wide sweep. Standing on deck with the ship rocking softly, you can watch the arc hold its place as the vessel moves. It can feel like the bow is tied to the boat. It is still tied to the sun and to you, but on an empty sea, the illusion is strong. By now, you have traveled through many layers of this gentle topic. You have stood in rain and spray. You have flown in your mind above a rainbow circle. You have peered into a drop like a tiny laboratory. The big picture is all in place. Light, rain, angles, and the steady patience of simple rules. How sleepy are you on a scale of 1 to 10? If you feel your eyes growing heavy, you can let the rest of this be a lullaby, a simple summary that brushes again over the highlights in softer strokes. The bow is a circle of light centered on the anti-solar point. The primary bow comes from one reflection inside each drop. Red sits outside, violet inside. The secondary bow comes from 2 reflections and reverses the order, sitting at a larger angle and looking dimmer. The darkness between them is a quiet gap that the paths of light do not fill. Supernumerary bands can appear as fine pastel lines inside the main bow, if drops are small and similar. Polarization gently hues the light, and sunglasses can change their brightness. From planes, full circles and glories may appear, while at night, moon bows stride pale arcs across wet, quiet landscapes. Your place on the ground is the center of your rainbow's circle. If you move, the bow moves. It is always true to your line of sight. This makes the bow private and shared at once. It belongs to each viewer. The sun's height shapes the bow's reach. Low sun makes tall arcs. High sun makes shallow ones, or none at all. Rain and sun cooperate for only a short time in any one place. That fleeting window gives the bow a gentle rarity, which helps the feeling that this is a gift, even though the rules are constant and reliable. Let the physics settle into a loose weave. Light enters each drop, slows and bends, spreads by color, reflects, and leaves, bending again. The exits crowd near certain angles, making bright edges. Many drops at those angles form the arc. The rest is context. Clean air and dark clouds make contrast. Drop size adjusts the clarity and the fringe details. Your eyes and brain render the colors with their own preferences and sensitivities. If you have ever seen a rainbow on wet asphalt from a thin film of oil and water, the colors swirl and shift in a different way. That is interference in thin films, not the same path as the raindrop, though the result is similarly colorful. The sky's rainbow has clean, ordered bands set by refraction and reflection. The road's rainbows are irregular bands set by differences in film thickness. Both are gentle pleasures to watch while you wait for the kettle to boil or for a train to pass. Rainbows in art have a long history. Early painters sometimes drew them with only 3 colors, more like a tricolor flag. Later artists included more shades. Modern cameras show the continuous gradients. In stained glass, rainbow themes bring a window alive with light that changes through the day. The science and the art meet here. A rainbow is a study in gradients that shift slowly, and this is an idea that designers and painters use to create calm. Children love rainbows. They point, smile, and look for the second arc. They might ask where it ends, and you can tell them it has no end, only a direction. You can carry that feeling with you, that the world offers patterns that are both understandable and endlessly open. Knowing the rule does not drain the magic. It often adds to it. Sleep likes this kind of magic, the kind that does not ask you to struggle, but simply to notice and to breathe. Even during a thunderstorm, when the sky seems loud and bright with flashes, the rainbow waits for the rain to soften and the sun to return. The moment the sun's rays can reach you and the raindrops ahead at the right angle, the arc appears. It does not force itself into view. It comes when invited by geometry. This is a good model for how to rest. You let conditions set themselves, then sleep arrives on its own, without being chased. If the bow seems especially bright at the base near the horizon, especially over water, you may be seeing additional reflections and the high density of drops concentrating the effect there. The surface can also reflect the colors and create small stretches of doubled brightness. Lakes and oceans are gentle mirrors that add their own accents. On rare days, a bow can appear in the spray of a fountain in a city square. People pass by with umbrellas and coats, and the arc hovers for a while in the droplets. It can make a place feel softer. If you live in a busy area, these tiny pieces of sky optics may be your closest connection to the wide, calm scenes of nature. Taking a minute to notice them is a small act of care for your senses. When rainbows show inside rooms, made by crystals or prisms, pets sometimes chase the colors across the floor. This adds play to the calm. You can join by moving the prism gently and letting the colors drift like leaves on a stream. The connection to the big sky bow is direct. The same story is being told, just in miniature. You can store in your mind a simple checklist that does not feel like a task. Sun behind you, rain or mist ahead, low sun for a tall bow, a dark background if possible. You can step outside after a shower and let this list sit quietly in the back of your mind. If a bow appears, you are ready to greet it. If not, you have still spent a peaceful minute outdoors, watching the way light lays itself over the world. The next time you see a rainbow, you might also notice the ground light. The colors reflected from wet streets and leaves can look richer. This is because wet surfaces become smoother on a small scale and reflect more like a mirror for shallow angles. Colors glow back up at you. The world feels glossy and new. A rainbow works hand in hand with this fresh look to make the post-rain light feel special. It can be pleasing to remember that the bow you see at one place in time is unique. The exact distribution of drops, the sun's height, the wind, the temperature, the landscapes that frame it, and your own eyes all set the scene. Even if you stand in the same place tomorrow at the same clock time, the bow, if it appears, will be a sibling, not a twin. This uniqueness holds hands with the reliable physics. Both together make a friendlier world for the mind to rest within. For all its calm, the rainbow also teaches patience. If you look too soon, while the sun is still hidden, you see only gray and wet. If you look too late, after the rain is gone and the drops have fallen, there is no medium left to bend and reflect the light. The moment is small. When it arrives, the reward is mild but deep. The sky shows its inner order, and you get to enjoy it for free, with no effort beyond looking slowly. Nature has many arc forms: the bow in spray, the halo around the sun or moon in thin cloud, the circumzenithal arc like an upside-down smile high overhead, the tangent arcs that touch a halo, the sundogs that sit like bright patches beside the sun. Each has its own story. The rainbow is perhaps the easiest to love. It asks for water and sunlight, two elements tied to life, and then it offers color. This closeness to daily experience makes it a perfect companion for a sleepy mind. It brings science into a place you already feel comfortable with. If you are near sleep now, let the rest be even more gentle. Feel your breath slow. Let your shoulders drop. Picture a soft green field after rain. The sky to the east is still gray, but the cloud is thinning. The west behind you is open and warm. A low sun steps out. The first stripe of red climbs into the air. Then orange and yellow follow, slow and sure. Green and blue wash in. Violet tucks into the inner edge like a ribbon. The whole bow completes itself and rests in place, like a painting that dries in moments. You may think of the people across your city or across the hills who are also seeing it at the same time. Each person has their own bow. Each one is looking at their own set of drops. Yet all of you share the sight. It is a quiet community formed by light. It stays for a few minutes, maybe a half hour in wide conditions, and then it fades as the sun rises higher or the rain moves on. The memory remains, a calm notch in the day. As the arc fades, some colors go first. Usually the blues and violets lose their vividness as the light grows more diffuse. Reds and oranges may hang on a little longer, warm and soft. Then the whole band slackens and melts into the sky, leaving only a slightly brighter patch that soon becomes nothing. The world returns to its regular shades. The science that made the bow does not go away. It simply waits for the next chance. If you carry a small pocket prism or even a phone with a diffraction grating accessory, you can look at the spectrum of a lamp at home. You will see a pattern of lines and bands that reveal the source. Fluorescent lamps have bright lines. LEDs sometimes have peaks and valleys. The sun's spectrum is smooth. The rainbow is the sky's way of projecting that smooth spectrum onto a giant canvas. Knowing this makes each bow a little like a note from the sun to you. If you have ever flown through rain at an angle where the bow is visible, you may recall the startling moment when the circle appears and stays steady as the plane moves. You can hold that memory. It is a talisman for the mind. It says that there are large patterns around you all the time, some of which become visible only when you change your point of view. Sleep also changes the mind's point of view. It lets deeper patterns and stories surface. Rainbows and sleep are friends in this way. Take one more slow look inside a raindrop in your mind. The surface is smooth. Light touches it. Part reflects away.
part enters and bends.
Colors spread, not because the drop pushes them apart on purpose, but because nature is consistent and gentle in how it treats different wavelengths. The light sweeps across the drop's interior, reflects, and exits. It bends again and heads toward your eye at a soft, favored angle. Now multiply this by countless drops sprinkled through the air. The result is an arc that feels both inevitable and surprising every time. You can let go of the details now if you wish. You can simply hold on to one idea. A rainbow appears when sunlight meets raindrops at the right angles. The drops bend and reflect the light, and the colors separate in a way that your eyes can see. This repeats across many drops. Your position selects which drops contribute. The result is a bright, gentle arc. There is nothing to solve, nothing to fix. It is all already working. When you are ready to sleep, this thought can be your last one. The world follows simple rules. Those rules, when arranged by wind and sun and cloud, make beauty. You are part of that world. You can rest in it. If you stay awake, you can look for rainbows another day. If you drift off, you can let the arc follow you into a soft, colorful dream. So, in the end, how does a rainbow appear from rain and sun? Sunlight carries many colors. Raindrops bend and reflect that light in a precise, gentle way. The angles for each color line up into a circle centered opposite the sun. You stand at the center of your own bow and watch the colors unfold. Thank you for sharing this quiet moment. If this helped you relax or learn something small and soothing, a soft like and a gentle subscribe will help you find your way back to more calm science whenever you want to drift off again. Sweet dreams.